Hey students, so this is the video notes for section 10.5. We're talking about angles, but we're more talking about triangles inside circles and then other congruent parts and theorems that just have some basic congruent parts. Okay, you're going to see as I'm doing the video notes, I've already drawn the pictures, so you can pause the video, draw the picture, and jump right back in, but I'm going to just move on and pretend that you have a pause button. Okay, so what's happening is we're looking at 60-degree angles, 90-degree angles, and 120-degree angles in our circles, and the neat things that these are going to create. On each of these problems, what I recommend, do not put the degree here because we're getting ready on every single problem to drop the altitude. So the definition of an altitude is the perpendicular segment that drops from a vertex to the side across from it. The altitude is how high something is. So every time we drop that, but then I want you to envision what you just created. If this was 60, now because the altitude has dropped down and these are both radii, they're equal. Because these are equal, it makes everything equal. And so what happens is this now has become a 30, 60, 90 triangle. Okay, so let's put in A is 8 radical 3. At the top of our paper or somewhere, let's just write our ratios just so you have them in front of you. If this is 30, this is x, x radical 3, and 2x. And then we're going to go ahead and get that 45, 45 on here because we're going to need it too. X, x, x radical 2. Okay, just so you have those for when we need them. So remember, if the problem starts with a radical, we need to end with a radical. And so this is my hypotenuse, so that means 2x equals 8 radical 3. 2x equals 8 radical 3, which is super easy. We're going to divide by 2. Oh, so sorry. We don't need that radical there. Here we go. 2x equals 8 radical 3, and then divide by 2, and we get x equals 4 radical 3. So that means across from the 30, this is 4 radical 3, 4 radical 3. Well, what do you notice? This piece right here is also 8 radical 3. Okay, AO is 8 radical 3. We're going to come to a conclusion, but we're going to look at one more problem to verify that conclusion in just a minute. Okay, let's jump to number 2. So I have a right triangle. When I drop this altitude, we have now taken a 90 and everything is equal because these pieces are equal. Everything is equal. And this is now a 45, 45, 90 triangle. And so we are given what? AT is 8, so that means this is 4. So this is 4. This is 4 radical 2. So BA is 4 radical 2. Because we've already covered 30, 60, 90, and 45, 45, 90, your work is minimal. And if you can do the part in your head, that's what we want you to be able to do. Okay, so now we've got our 120. When I drop the 120 and drop the altitude, because these pieces are equal, these pieces are equal. 90, this 120 has now turned into 60, and there's my 30. So this time, this is your x. Be careful on these. So Rn is 10 radical 3, okay, which means this is 10 radical 3. And so that is my 2x divide by 2. So that means this is 5 radical 3, and this is 5 radical 3 radical 3. Remember, it's x radical 3, so 5 radical 3 radical 3, which is 5 times 3 and 15. The question says, what is UN? So UN is 30. Okay. All right, we're going to do 1, 2, and 3 together. You're going to do 4, 5, and 6. Give me just a second. I'm going to draw my triangles. Okay, you can go ahead and pause and get your triangle set up if you haven't done that already. So number 1, I have that angle B is going to be a 60-degree angle, and BR is 4 radical 2. So this is my 30. Okay, so x radical 2, or x radical 3, and 2x. So 2x equals 4 radical 2, divide by 2, x equals 2 radical 2. Okay, so that means across from the 30 is my 2 radical 2. And the question says, what is IR? IR is 4 radical 2. Okay. Next one, number 2. So we have a 90-degree triangle. Drop the altitude. It becomes 45, 45. And HU is 16 radical 2. Okay. So this is x radical 2. If x radical 2 equals 16 radical 2, then x equals 16. So this piece is 16. This piece is 16. UG is 32. See, these aren't bad at all. And then we have our 120-degree angle. So this is my 30, that's my 60. We are told that RO is 12. Okay, so this is x radical 3, 2x. 2x equals 12. X equals 6. That means this is 6. This is 6 radical 3. And then we want OW, which is 12 radical 3. 12 radical 3. To make those bigger. All right, you are going to do 4, 5, and 6. I do want you to draw your own picture, and I do want you to get the answer. I will stop after each one to check to see if your answer is correct. Let's go ahead and start with number 4. All right, number 4. So we drew a 90-degree angle. This becomes a 45, 45, 90 triangle. We're told that AT is 20. So that means this piece is 10, this piece is 10, this is 10 radical 2. I don't see how you would need to have to do any work for that problem. You should have got 10 radical 2. All right, move on to number 5. Okay, number 5, we drew a 60-degree triangle, and so this is my 30 now, 60 cut in half when I drop that altitude, 30, and we are told that OP is 8 radical 3. Notice I put 4 radical 3 and 4 radical 3. That is my x. This is my x radical 3. So I did 4 radical 3 times radical 3, even though I don't need that. And then this is my 2x, so multiply this by 2. You should get 8 radical 3. All right, do number 6. All right, number 6. So we have a 120-degree angle drawn. When I drop that altitude, this becomes my 60. This becomes my 30. We are given that UT is 24, and so this is 12. This is my x radical 3. This is my x. This is my x radical 3. X radical 3 equals 12. Divide by radical 3. Multiply by radical 3 over radical 3. I kind of did a little shortcut there, by the way. So divide by radical 3, multiply by radical 3 over 3. What it does is it takes that away. And then reduce, we get 4 radical 3. So this piece right here is 4 radical 3. And I want to know what NT is. It is 8 radical 3 because it's 2x. 2 times this is NT, 8 radical 3. All right, let's go to the next page. So these theorems on the next page are super, super, super easy because they are very symmetrical. Okay, so when you have some pieces where you have 2 pieces congruent in a circle, it just brings out all sorts of congruent pieces in the circle because we have a lot of side, angle, side congruency happening in these problems. Okay, so in our first one, in this picture, it says, in the same circle or congruent circles, 2 arcs are congruent. So these 2 arcs are going to be congruent if, and only if, their corresponding chords are congruent. So looking at the pink, if those 2 pink pieces are congruent, then the chords that, the arcs that the chords are creating are also congruent. And it looks that way. You guys can go by looks. That's going to work out. Now, the reason this happens is because this is a shared side. This is a radius, so these 2 pieces are equal. This is a shared side. These 2 triangles are congruent by side, side, side. These 2 angles are congruent by CP, CT, I could ask you guys to write a proof showing that these 2 arcs are congruent, Arc AB is congruent to arc BC by the fact that the central angles create congruent arcs. If the central angles are congruent, then the arcs are going to be congruent. Okay, now let's take a minute right here just to review some things that you're going to need possibly throughout the rest of this worksheet, because anything that I've taught you already can show up. And I want to review. If this angle here is 50 degrees, then this arc would be 50 degrees, 50 and 50. Okay, if this angle is 50, this arc is 50. Okay, this angle here is an inscribed angle, so I want to remind you. Oh, we're actually going to do this problem in a minute. Let's use the answers to this. Let's go back. Let's do this problem and use the numbers from this problem. All right, if AC is 160, which is right here, then BC, okay, that means these two pieces are going to be equal because these chords are equal. 360 in a circle, so take 360 and subtract 360 minus 160 is 200. So that means this has to be 100 and this has to be 100. Now, if this arc is 100, this angle is 100. If this arc is 100, this angle is 100. If this arc is 160, this angle is 160. This angle here is an inscribed angle. And remember, an inscribed angle, because we talked about it very briefly in the circle vocab notes, that an inscribed angle is half of the arc. Okay, so this angle is half that arc. Angle B would be 80 degrees. And then there's all sorts of things that can happen in here. This is going to be 100. This is going to be 40. This is going to be 40. Just so many things that we've learned that we can apply to these problems. So to complete what's written down, AB is congruent to BC. Okay, if the arcs are congruent, then the chords are congruent. If the chords are congruent, then the arcs are congruent. And then this was 100 degrees. Okay. All right. The next one says, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So that means in this picture, these two pieces are equal and these two pieces are equal. Okay. And don't they look equal? You can fold that circle in half. Everything is going to map on top of each other. Lots of things can happen in here. We can have a right triangle drawn. Anything can show up with things that we've learned, Pythagorean theorem, and so on. So in the theorem part right here, if DE is congruent to EF, then the measure of arc DG is congruent to the measure of arc GF. There we go. Okay, in this picture, I'm not going to do this problem. These two pieces are equal. We are so beyond doing simple problems like that. Okay. All right. The third one says in the same circle or congruent circles, two chords are congruent. So these are congruent if and only if they are equidistant from the center. So let's talk about that word. What does it sound like? Equidistant, equal distances. So the problem is saying, or the theorem is saying, if these two pieces are equal and perpendicular, okay, they have to be perpendicular to show this is the straight distance, because you can't have the shortest distance is the perpendicular distance. Okay, so the shortest distance, that's why it is going to be perpendicular. So if these two segments are equal, then these two chords are going to be equal. Of course, you can see that we can put right triangles in there again and do all sorts of things. Okay, and by the way, if these two are equal, then these two are equal. See how that works? Okay, so to fill in the blanks, EF and EG would be congruent. Okay, so in this problem down here, this is going to be the last thing that I ask you. It's going to be your last question. Find HK. So I want to find this distance here. If DG is equal to JL and they both equal 24, and DH equals 13. So DH is 13. This is 24, meaning this is 12. What is this value here? If you put 5, you are correct. You should have got that was a triple. You should not have had to do the Pythagorean theorem. So if this piece is 5, then this piece is 5. HK equals 5. All right, we are all done with the notes. Thank you, students. Oh, before we go, let me just make sure you understand one thing. Anything can show up on your worksheet from what we've learned already. So it is going to incorporate any knowledge that we've had from the previous worksheets. All right, thanks, students.